There's something, quite honestly, a bit unsettling about that word, hope. At least to me, it is. And I've been sort of picking at it ever since Deborah originally asked me to speak today and then said, oh, by the way, you're on the panel called The Future of Hope. And I can see it makes sense. After all, I am the editor of a magazine that takes as its mission the vision or the mission to be the ultimate guide to what's new and what's next, and to deliver to our readers month in and month out the future, now. And in part because who would actually want to be responsible for delivering a rancid future ever, never mind now? We tend to share with our readers a belief that the future is going to be better. So we're a very optimistic magazine, and in that sense, it makes very much sense for me to be up here talking about trends in science and technology that I take hope in. But isn't there some kind of implicit judgment inherent in even the phrase, the future of hope? It's like, oh, God, it's such a shitty world. I hope you got to give me something I can be hopeful about. And the fact is, I am, constitutionally and professionally hopeful about just about everything. So if you take that, if we can stipulate that I am hopeful about everything, I will say that I did go through a little over a year's worth of Popular Science magazine to see what in the pages of the magazine that I publish would inspire a particular sense of hope and hopefulness in me, such as the extraordinary actual human organs that Anthony Atala and his large and well-funded group down at Wake Forest University are growing using, say, bladder cells harvested from a patient, and then cultivating them, and then spitting them out and printing them using inkjet printing technologies in a 3D matrix to create actual organs that can be implanted. They've succeeded with bladders, they're working their way towards kidneys, and God knows what will be coming next. Or the nifty portable brain-chilling device named Rhino Chill, naturally, that squirts a mist of perfluorocarbon coolant through tubes into the nasal cavity of a cardiac arrest victim, on his way to the hospital, where it cools the blood running to the brain down to 93.2 degrees Fahrenheit, and thus, in so doing, decreases the risk of dying, and by 15%, and among those survivors, increases or decreases the risk of brain damage by a further 15%. Andre, I'm going to race through these because they're dancing in Andre's territory, and I don't want any fact checking on this presentation. We've covered recent advances in understanding these still seriously mysterious processes that lead to age-related memory loss, and we've focused on the finding, I'm sure somewhat provisional, as all these things are, that treatment with a class of compounds known as histone deacetylase inhibitors, does that seem properly pronounced? Could significantly slow memory loss in Alzheimer's patients, possibly for years. Or, and you'll have to really forgive me here, Andre, the neural decoding research that Jack Gallant and his team at Cal Berkeley are doing, which has them steadily advancing, I will say in my hypey magazine editor mode, toward a day when he'll be able to reconstruct sequences of images in a person's brain by running fMRI or magnetic resonance scans through the presumably ridiculously powerful algorithms he and his team have developed. Eventually, Gallant believes he'll be able to read someone's mind, tell what he's seeing in real time. Now, I'm not sure if that vision actually fills me with hope so much as something closer to horror, but still, it's pretty awesome, right? I mean, so that's what and the crazy thing is, it sort of goes to something, the fundamental lesson that I have learned since I became the editor of Popular Science, and that is, if you can imagine it, as long as it doesn't violate the laws of physics, it will happen, basically. The tremendous and rapidly escalating advances in the pace of improvements in processor speed, data speed, energy efficiency, and all these various factors that drive innovation, drive our ability to learn new things, pretty much mandates that if you can imagine something, it will eventually happen. And so, with that in mind, I'm going to zip through a few sort of more broad trends that I saw emerging from my investigation of what has been published in the pages of Popular Science, and that I think are basically driving, the future, essentially, in the short and the long term. And the first one is the networked world. Whether purpose-built by researchers themselves or more likely as a natural, if not fully intended, consequence of the distributed communications lines and devices that ever more emphatically define this world that we live in today. Networks and sensor arrays are everywhere, and tomorrow they will be everywhere squared, and scientists will find ever more creative ways to leverage them, both to perform coordinated swarm-like tasks and to gather that lifeblood of all inquiry and knowledge data. So, like this tiny almond-sized mechanical robo-bees that two Harvard electrical engineers are building with a $10 million NSF grant, with the goal within 5 years of having dozens of bees flying in coordinated swarms, monitoring environmental hazards, or searching for survivors after a natural disaster, or pollinating flowers, quite possibly. Or the technology the Department of Homeland Security is developing that would allow every new cell phone to function as a chemical detector, sniffing out hazardous spills or leaks, alerting authorities with geographically pinpointed information. Your cell phone will be calling 911, even as, in one instance, you're actually on the floor because of carbon monoxide inhalation. Or this idea, to take advantage of an as yet underutilized mobile network, the well-distributed fleet of 218,684 U.S. Postal Service trucks, and turn it into a data gathering network measuring air pollution and ozone levels, or scanning for biological and chemical agents. There's a lot of thinking along those lines these days. Or detecting and reporting Wi-Fi and cellular dead zones. Anything you can think of. But you've got, 218,684 nodes out there to play with. Or the Ocean Observatories Initiative, which will wire the Pacific and Atlantic with sensor arrays to monitor ocean temperatures, acidity, and other variables in real time. Or Icarus, the International Cooperation for Animal Research Using Space, an ambitious plan to glue tiny transmitters to the bodies of potentially dozens of species of birds, winged mammals, and insects to track their winged migration with an eye toward predicting weather, stopping disease, and saving species. Did you get a good close enough look at that last one there? There's the sensor glued to the bee's body. Ah! Sorry, that's the sort of puerile adolescent humor that really works with my core constituency of adolescent boys. So another trend that is overwhelmingly evident is this, the power of data, or more importantly, the power of processing data. A few years ago, I was in the audience at the TED conference, and Tim Berners-Lee, the inventor of the World Wide Web, was up in front of the auditorium, leading all of us in, ever more propulsive chants of more raw data now, with the idea that, of creating a sort of internet of data, a new internet of data, with just tons of raw data out there waiting to be crunched and analyzed for whatever extraordinary new insights can be gleaned from them. But the thing about raw data, however awesome, is that it's nothing without the processing power needed to effectively crunch it. And with processing power traveling that relentlessly exponential growth curve, every day brings us closer and closer towards data crunching nirvana, enabling some jaw-dropping projects. My favorite one, example of this was also at TED. It was this year. It was Deb Roy, who, let me get this right, is the director of the Cognitive Machines Group at the MIT Media Lab. He took us through a project that he had started a few years ago that involved outfitting his entire home with video cameras, usually shooting from above, and audio recording devices that were motion controlled, and that the whole system that was turned on the day that his first child came home from the hospital. And over the next several years, they gathered 90,000 hours of video and audio, which is, I mean, I don't want to really have to worry about the therapy bills, I guess, later on, but at least they'll have evidence of what happened to lead to what the therapy was caused by. But if you have 90,000 hours, that's great, but what are you going to do with it without the processing power to really go through it and filter it, search it, crunch what you're seeing there? But they managed to do so and have managed to tease out some extraordinary new insights into the acquisition of language by human beings. So, we haven't actually written about that in Popular Science, but we have written about, let's see, the Biobank, a $100 million British research project that's gathering in-depth genetic, biomarker, and lifestyle information, blood, urine, saliva, waistland and heart rate measurements, how do you like your tea, hot or cold, that kind of thing, honestly, for more than 500,000 people to help figure out how to tailor medicine to individuals. Or collaboration between researchers at Arizona State, Woods Hole, and Microsoft to create a searchable database of high-resolution 3D images for every one of the world's 1.8 million known species. And data-driven efforts to track shark migrations, predict their behavior, and possibly create a shark attack early warning system, analyze ocean currents and predict the occurrence of hugely destructive rogue waves. Oh, whoops, I'm one ahead of myself. And analyze radon levels to help predict earthquakes days before they happen. Now, I would be betraying my constituents, those adolescent boys, and all of us who think like them, if I didn't say that I find tremendous hope in the advances in the development of our robotic helpers. There you go. But overlords, I mean, hasta la vista, human ping pong player. This is a ping pong playing robot. It's like, it's from Vietnam. I love, I love the shades. I love the menacing look about it. I would crumble before it. But it has, this is Topio 3.0. It's from Vietnam. Uses two 200 frame per second cameras to track the ball as it leaves an opponent's paddle, and then uses its artificial neural network to analyze the ball's path, choose the best return. It has not beaten a human yet, but it will. It will. It is inevitable, I'm telling you. This extraordinary specimen of robotic manhood does raise this intriguing question, which I'm sure has bothered all of you at various times, and that is, where is my humanoid robot butler? I mean, Star Wars, when was that? 1976? I'm still waiting for C-3PO. I want Rosie the robotic maid from the Jetsons. Why has this not happened yet? And it's interesting, we've covered the humanoid robot question in the magazine. And I will not, I'm loath to indulge in cultural generalizations, but one of the reasons why humanoid robots in particular have not really taken off, or in the past hadn't taken off in the United States, has to do a lot with essentially cultural priorities that we have and the way that we fund research here. It's hard to make a case for a humanoid robot on an incremental basis. Americans like to see progress step by step, and they fund things based on, typically funding comes based on the notion that, each of these steps is going to be, an important, practical, pragmatic step forward. And when you make a case that, well, the whole point about developing humanoid robots, besides the fact that you can make a very strong case that in the future, any robot that is developed to look and, ambulate and behave in the way we do physically will be far better able to navigate our own houses and living spaces. But besides that, a humanoid robot, is a system of systems, and its value to researchers in robotics is entirely, in many ways, based on the challenges of integrating those together and creating a truly synthesized platform. Now, in Japan and Korea, where robotics research, humanoid robotics research is far, far advanced from where we are, they have no problem thinking along those lines. In fact, it seems to energize them in a certain way. And they also tend to, again, culturally be willing to imbue a sort of physical, if not living, breathing sort of being with sort of the notion of having properties, like almost human-like properties. And it's very important for them to care about that. So that's driven that, but we see now Dennis Hong, a researcher at Virginia Tech, and his group are making great strides in developing low-cost humanoid platforms. And again, it is inevitable that over time we will incorporate robots, humanoid and otherwise, into our homes and into our lives at an extraordinary rate. Here is Bandit, a robot that is being used even now to treat autism patients and try to help forge a stronger bond with humans. There are and will be more and more robotic beings, whether humanoid or not, that are used to enable and help us as we age and become disabled in particular, and help us live more rich lives regardless of whatever disability we have. But honestly, demographics alone dictate that within the next 20 years, we will have to be incorporating far more in the way of robotic aids into our homes because, we're just getting older and there ain't enough younger people coming in to take care of us human to human. So we're going to need robots in our homes. I'm telling you, it is inevitable. So I want to mention, obviously, I am standing here sort of on the shoulders of my entire staff of, as I say, much smarter people than me. This is sort of a true example of crowdsourced insight, not only because I pillaged the pages of Popular Science magazine to pull these things out of it, and I didn't research and write all of those things, but also because I also sent out to my staff of very smart people an inquiry asking them to tell me what new advances or trends give them hope in science. And I wanted to share with you one from Martha Harbison, who is one of my absolute core staffers. It's very difficult to find the balance between people who are true scientists, essentially, and who can deliver that information in a very accessible way to an audience, in our case, of 7 million people every month. But Martha is extraordinary at it. She's a PhD scientist in biology and chemistry, and yet she more or less speaks English. But I'm gonna quote from what she read back to me, and I want you to pay close attention to the enthusiasm, basically, in her tone, essentially. For me, she said, one of the greatest trends of the last 2 decades is our ability to see, literally see, the natural world in high detail due to the invention of technologies such as the scanning tunneling microscope, the confocal laser scanning fluorescence microscope, say that 10 times fast, and improved MRI techniques. These new imaging techniques have revolutionized medicine, material science, molecular biology, physics, and chemistry. Basically, all scientists thrive on data that we can crunch, but sometimes a picture is really the best way to grok something fundamentally. To understand spatial relationships, or understand how a cell changes shape or chemical composition over time, and where those changes happen. Or it helps doctors understand a patient's ailment and how best to correct it surgically to be able to see in high detail the affected organs. Scanning tunneling microscopes reveal the structures of surfaces in atomic detail. Confocal microscopy takes images of cells in 3D and shows with exquisite detail the physical locations of proteins and structures within the cell or on its surface, which is important for cancer and infectious disease research. I'll end, she says, with one of my favorite science pictures of all time. It spurred me to finish my biology degree more quickly so I could pursue chemistry in addition. It was published in 1993, and I still love looking at it. That's a quantum corral. The spikes on the circle perimeter are cobalt atoms. Those ripples in the middle are electrons, the standing waves of electrons predicted by quantum mechanics. Rather than just being a mathematical construct that only a physicist can understand, it is plainly visible to anyone that, holy shit, we took pictures of electrons. And even better, holy shit, quantum mechanics actually works. These days, well-heeled high schools have scanning tunneling microscopes. Picking up individual atoms and moving them around is old hat. Back then, it took multiple physics postdocs to build that corral, and it earned Don Eigler the 2010 Neuroscience Kavli Prize. For me, she says, but for me also, knowledge is power. Better materials will make better photovoltaics or better batteries or safer chemicals. Better understanding of cells will make drugs with fewer side effects. Better understanding of illness will make treatments easier. Knowledge drives hope. For through understanding, we can find solutions to the problems that vex us.